Bachelor? Stoichiometry. It's just a fancy name, but it's actually very easy. Alright? Now, I'll just give you an example. Let us make our Emma Darcy. Alright? Okay, now, let's say you need 5 chilies and 1 slice of cheese. 1 slice of cheese, and let's say you get 1 plate of Emma Darcy now. Alright? Forget about sour and oil, okay? I'm just focused with the main ingredient. We need chili and we need cheese, right? So let's say we need 5 chilies, right? 5 chilies and 1 slice of cheese, and you get 1 plate of Emma Darcy. Now let's say you have 3 friends now. Now you want to make 3 plates of Emma Darcy. So how much of this ingredient do we need to take?
Times 3.
Times 3. Meaning now we need 15 chilies, then 3 slices of cheese to get 3 plates. Right? So these things, this chilies and this 1 slice of cheese, this will tell you how many plates of Emma Darcy you're going to get, right? So in a way, stoichiometry is that one. Alright? It is the recipe maths of chemistry. So you need 5 chilies, 1 slice to get 1 plate of Emma Darcy. So we know now if you need 3 plates, how much you're going to take, right? So that is actually stoichiometry. So instead of chilies and this cheese, what we have is now, okay, now instead of chilies and this cheese in chemistry, we have N2, nitrogen gas, hydrogen gas to produce ammonia. Now this is a balanced chemical equation. So here we have N2. So N2 plus we have 3H2, then we get 2NH3. Now these are called stoichiometric number. There is nothing here, so which means 1 is there. Now these are the stoichiometric numbers. This will tell you in order to get 2NH3. Now this number, it can also represent, what is it? Mole. So you have 1 mole of nitrogen gas is reacting with 3 moles of hydrogen to give us 2 moles of ammonia. Meaning, just like I said, if you want to prepare 3 plates of Emma Darcy, how many cheese and Emma you need, right? So similarly, if you are to produce 2 moles of ammonia, how many moles of nitrogen do you need to take? 1 mole and 3 moles of hydrogen. It will give us 2 moles of ammonia exactly. Okay, so these are called stoichiometric number. So this stoichiometric number, it comes from our balanced chemical equation. The chemical equation needs to be balanced to get that stoichiometric number. Okay, alright. So here, we can also say, in terms of volume now, 1 mole of nitrogen means we are reacting 22.4 liters. Because 1 mole of any gas occupies 22.4 liters. Right? Now, we have 3 moles. 3 moles of hydrogen gas, meaning in terms of volume, it is 3 into 22.4. Which means you are reacting 67.2 liters, right? Are you getting it? Why we got this 67.2 liters? Because there's 3 moles. That stoichiometric number represents moles. So, 2 moles of ammonia is produced, meaning 44.8 liters of ammonia is produced. Meaning, if you are asked to produce 44.8 liters of ammonia, you have to know how much of this reactant do you need to take in terms of volume. So we know 22.4 liters of nitrogen gas is reacted with 67.2 liters to get exactly 44.8 liters of ammonia. Can we also find in terms of mass? Yes. So 1 mole of nitrogen gas in terms of mass, how much is it? 2 into 14. 7? 7 is atomic number. So 2 into 14. So how much do you need to react? 28 grams of nitrogen. And then 3 moles of hydrogen in terms of mass is how much? 1 mole of hydrogen, weight. What is the weight? 1 mole of hydrogen, if you had only 1 mole, what is the weight? 2 grams. So we have 3 moles. So 1 mole. So 3 moles means 3 into 2. So 6 grams. So how much amount of ammonia will you get in terms of mass? 1 mole of ammonia, what is the weight? Ammonia. 14 plus 3. 17 grams, but now we have 2 moles. So 2 into 14. 17. So here we know 28 grams of nitrogen. If you react with 6 grams of hydrogen, you will get 34 grams of ammonia. So see, all this information we will get from the chemical equation, balanced chemical equation. Now, why do you think this stoichiometry is important in chemistry? To balance. Chemical equation is already balanced. How to balance? Sorry? Think about that emergency, right? So you have 3 friends coming over. So you know exactly what amount of chilies you need to take, how many slices of cheese you need to take. So, why do you think that is important? Sorry? To get a perfect dish result. Yes, if you take too much chili and less amount of cheese, do you think your emergency will be tasty? No. And also, if you know 3 friends are coming over, you know how much amount you need to take. So there is no waste, right? Yes? Similarly, in chemistry, if you want to prepare exactly 34 grams of ammonia, you know exactly how many amounts you need to take, right? Otherwise, if you do not get this number correct, you will never get the amount in correct figures. So your company will not run in loss, right? You will not waste chemicals. You will save lots of money because time is money, right? Yes? So that's why stoichiometry is really important in chemistry. Okay? So if you know that stoichiometric figure, how much amount of reactants you need to take in order to get how much amount, like I said, the reactants or product will not go in waste. Otherwise, if you say you need that your company want to sell 100 grams of ammonia, you need to figure out how much this and this you need to react. Okay, so that's why stoichiometric number is really important. Okay, so remember, we get all this information from balanced chemical equation. So the following calculations we are going to do will be based on chemical equation, where you need to consider stoichiometric number, whether it is 1 mole, 2 moles, whether you need to take in volume or whether you need to take in mass. Okay, so let us try calculations based on chemical equation. So first, mass to mass relationship. You will understand why it is called mass to mass relationship. Okay, let's look at this question. In the following chemical equation, if 5.3 grams of ammonium chloride are used, calculate the mass of calcium chloride produced. So first step, what are you going to do? So the chemical equation is given. They are saying if you have 5.3 grams of ammonium chloride, what is the formula of ammonium chloride? From this chemical equation, which one is ammonium chloride? NH4Cl. You have to correctly identify the given substance. You have to know its formula, right? So that's where your radicals comes in. Your radicals, then you crisscross the valencies and you get the chemical formula, right? Ammonium NH4Cl is, their valencies are 1. That's why the formula is NH4Cl. And next, what is the question asking you to find? Calcium chloride mass. So where is calcium chloride? In reactant side or the product side? Product side. What is the formula? CaCl. So right now it's highlighted for you, but in exam you have to know the relationship between which two substances the question is asking. Okay. So now what is given? Ammonium chloride. Now the question says, in the lab, let's say you have only 5.3 grams of ammonium chloride. You want to find out how much calcium chloride will be produced. Now, we know the Emma Darcy's recipe, 5 chilies plus 1 cheese will give you 1 plate, right? Then next, if you want to find 3 plates, if you want to prepare 3 plates Emma Darcy, how much chili and cheese you need to take, right? Similarly, this question, what we need to do is first, find out how many moles of ammonium chloride is there in the balanced chemical equation. 2 moles of ammonium chloride gives us how many moles of calcium chloride? 1. There is nothing in the front, meaning there is 1, CaCl2. So this is 2 moles of ammonium chloride gives us 1 mole of calcium chloride. We got this information from the chemical equation. Now, they are asking mass of calcium chloride. How much calcium chloride will be produced when what is given? What is given? Moles, mass, volume, what is given? Mass of ammonium chloride is given. Meaning, here ammonium chloride mass is given. So, which means these 2 moles you need to convert to mass first. Now, this one we are trying to find that fixed recipe first. 5 chilies plus 1 cheese gives you 1 plate. That is fixed, right? So, we have to find that fixed one first. So 2 moles ammonium chloride in terms of mass, how much is it? If there was 1 mole ammonium chloride, find out the mass. 1 nitrogen, 4 hydrogen, 1 chlorine, find the mass. That is for 1 mole. And now you have 2 moles. Ammonium chloride, what is the mass? Nitrogen 14 plus 4 plus chlorine 35.5. So that is the mass for 1 mole. Now you have 2 moles. So what will you do? 2 into ammonium chloride. What is the mass for 1 mole? So is it 101 for 2 moles? 2 moles, is it 111 grams? Is it? 107. Okay, sorry. So 2 moles ammonium chloride is 107 grams ammonium chloride. You remember when we did nitrogen plus hydrogen ammonia, how we got that mass? This is that mass. 107 ammonium chloride is giving us how much mass of calcium chloride? Because the question is asking mass of calcium chloride given is mass, right? So how much mass is it? 1 mole calcium chloride. Calcium 40 plus 2 into 35.5. Is it 111? Yes? Okay. So 1 grams of calcium chloride is produced. We got this information from the balanced chemical equation. Did you understand why we converted to mass, this into mass? Because what is given in the question? Mass is given. They are asking mass of another substance. That's why this mole is converted to mass in both the cases. Now what is the question asking? They are asking you to find the mass of calcium chloride produced when instead of 107 you have only 5.35 grams of ammonium chloride. So you solve for X. So how much mass? If you start with 5.3 grams of ammonium chloride, how much calcium chloride will be produced in terms of mass, grams? 107 gives you 111. You have only 5.35, so it will be a little bit higher than 5.35. Look at the relationship here. Is it 5.55? Yes. 107 gets multiplied with X. This 2 gets multiplied. And then if you find for X, 107 will go into the denominator. So is it 5.55?
Yes, ma'am.
Yes. So did you understand how this stoichiometric number is used? Yes. So you want to know how much calcium chloride will be produced when you have only 5.3 grams of ammonium chloride. This number can change based on how much reactant is there in your lab. But this is fixed, right? Yes. This is based on chemical equation. It's saying 107 grams ammonium chloride will always produce 111 grams of calcium chloride. Now sometimes you might have to find this when the product is given. So based on this, you have to do the calculation. You have to know where to put the x. Right now I put the x here because the question is asking you to find the mass of calcium chloride, not ammonium chloride. Sometimes they will give you this product. Let's say you want to prepare 5.55 grams of calcium chloride. How much ammonium chloride will you require, Sachin? You will get this figure, 5.35. So you have to know where to put this in. So did you understand why it is called mass to mass? Yes, you have to understand first, you have to make the relationship from the chemical equation first. 2 moles, how many moles is it? Then you have to understand whether you have to convert to mass or whether you have to convert to volume. Right now it is mass to mass. Both moles you have converted to mass. Okay, now let's look at the next one. Now what is it? Volume to volume relationship. Which means, what do you think, how do you think will be the question? What will be given? Volume of one substance, and what will the question ask? Volume of another substance. So let's just look at this question here. Ethyne burns in air according to the following chemical equation. So the chemical equation is given. Now calculate the volume of carbon dioxide formed by 20 liters of ethyne. So what will you do? How will you start this? Ethyne, which one is ethyne? Which is the formula for ethyne? C2H2. Do you remember? Ethyne, the alkyne family, 2N minus 2. C2, hydrogen will be 2 times 2, 4, 4 minus 2, 2. So this is ethyne, right? So the relationship is between ethyne and which gas? Carbon dioxide. Do you need to look at oxygen and water? No. So like I said, you were saying when I said ematase and cheese, I did not mention oil and all these things, right? So you need not have to look at everything. So first, what is it? You have how many moles of ethyne? 2 moles of ethyne produces how many moles of CO2? 4 moles of carbon dioxide. Now, this is 2 moles. 2 moles of ethyne, when it burns, it produces 4 moles of CO2. Now, will you change this mole to mass, or what will you change? Volume. So 2 moles of ethyne will occupy how much volume? 44.8. Why? Because 1 mole of any gas will occupy 22.4 liters. Right now we have 2 moles, so times 2, that many liters of ethyne is burned. And how many liters of CO2 will be produced? If it is 1 mole, it will be 22.4. But now we have 4 moles, so 4 into 22.4. So 4 into 22.4 liters of CO2 is burned. So what is the question asking you to calculate, class? Volume of which one? Where is carbon? Where will you put X? Left hand side or the right hand side? Right, because CO2 is here. X. So what is given? 20 liters of ethyne. So this is ethyne. So liters. So here it is 20 liters. So how much CO2 will be produced? Did you get 40 liters?
Yes, ma'am.
Actually, this volume and volume is much easy. Doesn't matter what gas is it. If you know 1 mole, 2 moles, 1 mole will always occupy 22.4 liters. 2 moles means 2 into 22.4. You just have to know how many moles is taken. Okay, then we have mass to volume. So how do you think the question will be? What will be given?
Mass.
Maybe mass or maybe volume might be given. They might ask you to find mass. If mass is given, they might ask you to find the volume of another substance. So let us look at this question here. From the following chemical equation, calculate the volume and STP of carbon dioxide produced by 10 grams of calcium carbonate. So how many moles of calcium carbonate is there?
1.
Okay. So 1 mole calcium carbonate. So the relationship is between CaCO2 and CO2. So how many moles of CO2 is produced? 1 mole. So 1 mole CO2 is produced. Now question is asking what volume of CO2 is produced. Given is mass of calcium carbonate, right? Yes? Now from this here, first thing, 1 mole of calcium carbonate you need to convert to mass or volume? Volume. Because the given is calcium carbonate's mass, which is 10 grams. So first thing, from the chemical equation, you need to convert this moles to mass. So 1 mole of calcium carbonate in terms of mass, how much is it? Because the question is given in mass, you need to convert this moles to mass for calcium carbonate. Which is how much? Plus carbon 12 plus 3 into 16, which is 100 grams. So 100 grams of calcium carbonate produces now 1 mole you need to convert to volume. So 1 mole of CO2 will produce 22.4 liters of CO2. Now question is asking volume of CO2, so your X should be here, right? So how much mass is given? Calcium carbonate 10 grams. So from 100 grams you have come down to 10 grams. So how much volume of CO2 will be produced when you take only 10 grams? It will be much less compared to 22.4. You are only taking 10 grams, right? Solve for X. 100 gets multiplied with S, this and this, X 100. How much is it? 2.24 liters of CO2 will be produced if you start with 10 grams of calcium carbonate. So you see how this stoichiometric calculation is really important if you want to find out how much CO2 will be produced if you take only 10 grams. Okay, so this calculation is really important to find out how much amount will be produced and how much amount of something you need to take. So like I said, when you struggle, your brain is actually growing, okay? Your synapses are firing. The more you struggle, it's good for your brain. I'm not saying it, the neuroscience is saying that, right? It's all about growth mindset. You have to make mistake right now. And then please ask for help.